Hi, folks. Chris Voss here from the ChrisVossShow.com. The ChrisVossShow.com. Wow, that cracked on me. Thanks for coming by, guys. We certainly appreciate it. As always, to see the video version of this, the most amazing video version that's free for an unlimited time on youtube.com/Chris Voss. You can go there, hit the bell notification button. Also, go to goodreads.com/Chris Voss. You can see everything we're reading and reviewing over there. And you should follow me. I actually have an author page. So that's just like an added benefit, isn't it? I don't know. Maybe not. Anyway, go to Facebook, LinkedIn, Twitter, Instagram, all the places the Chris Voss Show and myself, being the Chris Voss part of the Chris Voss Show, are at. Because I don't know, it seemed like a good idea at the time. Anyway, guys, we have an amazing author on the show, much more amazing than myself. His name is Brendan Burrell, and he has written an amazing new book that is very topical. It's I'll let you be the judge, but it sounds very topical to me. It's coming out October 26, 2021, so you're going to want to take and pre-order this baby so you can be the first on your block to say you read it. The First Shots, the rival, or I'm sorry, let me recut that. The First Shots, the epic rivalries and heroic science behind the race to the coronavirus vaccine. And he's coming on the show. He's going to be talking to us about his amazing book and all the stuff he detailed in it. Not only that, he's an award-winning journalist and the author of this new book, and it tells the inside story of Operation Warp Speed. Over the last decade, his writing about science, health, and business has appeared in dozens of outlets, including The Atlantic, Bloomberg Businessweek, National Geographic, Wired, and the New York Times. He grew up in Texas, received a PhD in biology from UC Berkeley in 2006 before turning full-time to journalism. He lives in Los Angeles. Welcome to the show, Brendan. How are you?
I'm good. Thank you for having me here.
Good. And congratulations on the new book. This is always exciting. You get out of the editing process and get that book published, and now you got to go around and talk about it for the next 6 months or years.
Yeah, it was an epic scramble. I'm glad to relax and just be able to talk rather than have to write.
Most definitely. So give us your plugs so that people can find you on the interwebs.
Well, I'm Brendan Burrell. You can find me on Twitter at bborrell. The webpage for the book is just thefirstShots.com. You can pre-order the book there. And yeah, that's all there is.
There you go. So what motivated you to write this book?
Well, I mean, like everybody else, I mean, we all remember what it was like back in, January, February 2020. It's like we're going about life as normal. We hear about this strange new bug coming from China. And I had all my plans for, I'm going to go report in the desert here in California. I'm going to do this project, that project. And it just came to a halt. I mean, I couldn't travel. I was just personally invested in what was going on. I mean, we were all just reading the news every morning, like, oh my God. I have this background in writing about science and infectious diseases. And so I started pitching a few stories here and there. And it was kind of like it was becoming clear by March and April that the only way out of the coronavirus pandemic was a vaccine. And, historically, vaccines take years to produce, right? The fastest ever is the mumps vaccine. That was 4 years.
Wow.
Fauci was talking, 18 months minimum. And, it was clear that whatever was happening, that the vaccine story was the big one. And I wanted to be there following it. And, over the last 18 months, that is what I devoted my life to, is trying to understand everything that happened and how we got here. Yeah.
There you go. So give us an overall arcing of the book. So what's some of the details? I noticed you outlined some different people in here, or the players, if you will, of the game. You've even got some people called Wolverines and some other things. Give us a kind of overall arcing, if you would, of it.
Yeah, I mean, the book it's told chronologically across the pandemic year. I mean, I open the book the moment that the first coronavirus gene sequence goes online. There is this mysterious outbreak of pneumonia there in Wuhan. And after a bit of a delay, the coronavirus gene sequence goes online. And that's the moment when the clock starts ticking, right? Because now scientists around the world can start working on a vaccine. And so the book kind of tells the process here in the US of how the scientific race becomes like a business, a product, a vaccine, and how it becomes this political football, and with Operation Warp Speed and just all of the craziness we saw unfold in last fall around the rollout of the vaccine and Trump's election. And I wanted to take readers inside to the players who actually made this happen. So it wasn't just like the scientists. So we learn about scientists. It's like the public servants. It's the political appointees. We learn all of their stories and sort of how they were fighting to get this thing out. So that's kind of the arc of the book, and it's a pretty epic story that I feel proud to be able to tell.
Yeah, I don't think we've ever developed a vaccine or made it public this fast ever. Is that correct?
That's right. Yeah. I mean, some vaccines have taken decades to develop, and we're still not fully there. I mentioned the mumps vaccine, that was 4 years. This thing was 11 months from sequence to approval, and rollout. I mean, because we pre-manufactured this thing. So it is quite an accomplishment. And, I think a lot of people think, oh yeah, we've heard about vaccine hesitancy. You might have a friend or somebody says, well, I'm a little afraid of it because it was rolled out so quickly. But the speed only came because of, say, decades of research that had sort of gone into this ahead of time. Developments on the mRNA, which is used in the Moderna and Pfizer shots, and some of the dedicated scientists who were studying some of these weird viruses, and kind of had a strategy for how they would tackle it when they needed to make a vaccine.
Yeah, my understanding, correct me if I'm wrong, because you've done the study on it, but the mRNA blueprint sort of way of telling the body how to fight stuff isn't like overnight new. They've been working on it for years, and actually, I think they use it in a few other things.
It's been tested for a long time. I mean, people really wanted to do therapeutics with it, like make a artificial insulin or whatever. And that had sort of been the first attempts to use mRNA. And then I think there's an mRNA in some type of veterinary vaccine. I have to check that, but never before in humans. I mean, this is what's so remarkable about this. They basically sort of inched up closer and closer to the finish line over these last couple of years, but it was really just this incredible need for a vaccine, the amazing amounts of money that the government sunk into this thing, that allowed us to bring this thing across the finish line. And I think it's pretty clear that mRNA is going to revolutionize medicine for the next decade.
That would be awesome if they can fix things like insulin and stuff like that for diabetics and things.
Yeah, I mean, there's a lot of sort of rare gene diseases that, are kind of the targets that they're focusing on, where, rather than growing up a protein in a factory, you just give a person the gene and bada bing. Yeah.
We're kind of like computers, so you just give us a little schematic and we'll run with it, I guess. I don't know. So how do these?
That is what DNA is. Yeah. Yeah.
So totally. How do these vaccines work then?
Yeah, I mean, this is, what's a vaccine supposed to do? It's the basic idea is it's supposed to teach your body, how to attack a virus, parasite, like, or something like malaria, which is a single-celled microorganism. So it's trying to train your body. And so the way you do that is you give it sort of a weakened form of that thing, or you give it a piece of that thing. Because we all have, this incredible immune system, right? We, when we cut ourselves and we get, some type of infection, our bodies produce antibodies. And so we have this natural antibody response, but it turns, you're a little bit slower, if you've never encountered the bug before, as what happened with this new coronavirus. Like, so the point of a vaccine is give your body a little bit of a taste for it, so it's already got the defense ready. And so I think back in the early days, I mean, the first vaccine was, of course, the smallpox vaccine, and that's kind of used cowpox, a very similar type of virus, and by giving people this weak virus, you would be prepared when you get a smallpox infection. Later on, we started using killed viruses, like the polio vaccine was initially a killed virus vaccine. And then people started giving just little pieces of the virus, these protein-based vaccines, and then that led to mRNA. And kind of the idea with going with each step in this process is the smaller the piece of the virus you give, the more focused immune response you get, the less likely you are to have side effects and so on. Because this is the central challenge of a vaccine. This is what we face this year, which is compared to a drug where you are only treating sick people, a vaccine is given to the healthy people. So you're exposing a whole lot larger swath of the population. And it's a swath of the population that's healthy. And so you don't want to do anything that could cause harm to them. Even a rare side effect becomes a problem. And so that's why developing vaccines is so challenging, and it's done so slowly.
For the thoroughness of it. So do we, in the speeding this up, were we balancing, the destruction of our world and environment and financials and just everything? I mean, we just all be living in lockdown forever. Do we have to make a bet and exchange some risk for some security, or to get back to security for that matter?
Yeah, I mean that's always, there's always that balance. It's like, hey, how long do you want the country to be locked down? How, what is the risk of an elderly person getting COVID and dying and so on? And with the pandemic, there was clearly a need to move faster than normal. And it really caused the regulators at the Food and Drug Administration, for instance. I mean, this is a little known fact, but one of the architects of Operation Warp Speed is like the top guy at the FDA, Peter Marks. He's like this geeky cancer doctor, super passionate civil servant. And, he was well aware of this game of balancing the risk versus the benefit. And that was kind of the whole thing with an emergency authorization. It's like, all right, what level of, proof do we need? We don't need the full approval. We just need a really, really strong guarantee that this thing works and it's not dangerous. And so that's why they did shorten the timeline a bit, but they did the math and they said, you know what? Most side effects from vaccines occur within the first 6 weeks of a vaccine being given. And they decided that's how long of a safety follow-up they wanted before they were willing to give it an emergency authorization. Basically the way that the vaccine process was sped up was there's normally the biggest issue with developing a vaccine is the risk that your vaccine is going to be just a failure, a commercial failure. You spend all this money running these tests and it doesn't quite work good enough. And so companies sort of draw the process out. So they'll do one study and then they sort of hold their meeting, and then they'll do another, they'll invest a little bit more and a little bit more. And what Operation Warp Speed did was it said, hey, we're going to throw all this cash at you. We want you to do everything in parallel. We want you to take all that dead space out, and we want you to start manufacturing the vaccine before it's been proven effective. And hey, if it fails clinical trials, we'll throw it out.
I didn't know they'd started manufacturing before it was even approved. Well, I guess I kind of did. I didn't know how far along they were, how long the time took, but that's pretty amazing, actually. Right?
Yeah, I think the process of manufacturing a vaccine is just so complicated that, even, they wanted to start, manufacturing it immediately, but it did take quite a bit of time to start scaling up the process, especially mRNA, which had never been made on a commercial scale.
Oh, wow.
That's why everybody was super disappointed in December when, Pfizer's like, oh, actually, we don't have 100 million doses. We only have 20 million. But, they were working that whole time to try to scale things up.
And I remember one of the big things was the refrigeration issue and just trying to scale that, right?
That's right. I mean, it was frozen. I mean, these things Pfizer's had to be like -80 degrees Fahrenheit, which is ridiculously cold temperature. And I mean, how many, local doctors' offices have super freezers like that?
Yeah, like negative something or other. You're just like, whoa.
Exactly. So it was like the UPS hubs had to have freezers. Pfizer made these special boxes that would carry like 975 doses in these dry ice compartments. It was that was really something. That was the downside of the mRNA vaccines, is they hadn't sort of optimized the stability of it, because that's the original problem with mRNA. it's a very short-lived molecule in the body. It's very fragile, and that's why you have to keep it really cold.
Yeah. Plus, you got to make sure that 5G chip stays intact, right? No,
exactly,
I'm just
yeah.
kidding. Kidding, people.
Yeah,
If you think I'm serious on that, go seek mental help. But I do like getting the extra bars with mine. I got the Moderna. I think that gives me 3 bars on the AT&T network.
it is a more potent shot, yeah.
Yeah. I feel like I kind of feel like this is actually really a question, even though it sounds a little bit like a joke, or it comes from a joke that we just did. But it does seem, I kind of read everything and I've taken a lot of data, but I'm no scientist. That being said, I'm going to talk like I'm a scientist. No, I'm just kidding. It does seem like the Moderna virus or the vaccine seems to be like really good. And then there's the Pfizer one, and then the J&J is kind of like something you get in an alleyway or something. Am I getting that? Am I right there?
That's a
Or
little bit harsh.
I'm
Putting
just
on my,
kidding.
my public health hat, I'm just to be fair to them all. I mean, the thing is, all 3 of these vaccines are scientific marvels. They will stop severe COVID. I mean,
Okay.
J&J, first off, is that there were a lot of hopes on J&J because it was like it didn't need to be frozen. It was cheaper than the mRNA vaccines, and the idea that it could be effective in one shot. Operation Warp Speed basically pushed J&J to do it as one shot, tested as one shot here. It was tested as 2 shots in other countries. And but they thought, yeah, if we could do, one and done, that's like magic. And that, you would only have to produce half as many doses and so on. I mean, of course, it didn't work out. And that was as well as people had hoped. With the other vaccines, I mean, Moderna and Pfizer ended up going a slightly different route when they were racing through their development process. Moderna ended up with a 100 microgram shot. Sorry, I'm not getting this out. And Pfizer's was 1/3 of that size, and Moderna spaced their shots out a little bit further. And I think there were the experts told me that there were sort of pros and cons of these 2 approaches. I mean, the beauty of the Moderna shot was they were really siding on like, let's make sure this is effective as long as possible. The beauty of the Pfizer shot is, hey, you can stretch out the amount of material you have. You can produce more doses. You also can have fewer side effects. There are some studies that suggest that the reaction to the Moderna shot is more significant. People are really, it hurts. I didn't have that. I got the Moderna shot and I'm kind of fine. I didn't have a serious reaction, but some people did. And Pfizer definitely has experienced a little bit more of the waning immunity. And, whether it's, people are going to need Moderna shot. I mean, I know that 3rd shots have been approved for Moderna, but the data look like it kind of is going to last 3 to 6 months longer. Wow. And you're still pretty good off.
See, I knew it was better.
Yeah. Which one did you go?
I got the Moderna. Yeah.
Okay.
In fact, I only hang out with Moderna people now. I had to get rid of all my Pfizer friends and J&J friends because
right.
It's a club. I'm just kidding.
Yeah. Well, they had it's an interesting fall from grace for Pfizer, of course, because it was called the hot person vaccine and the status vaccine early on. I mean, Pfizer came at it and they put all of their own money in it. They didn't have to deal with the warp speed that much. I mean, they did interact with them in certain ways, but whereas Moderna was kind of the little guy, the David versus the Goliath.
So what did Pfizer get out of being first? I guess they were first to the race, so getting it out.
Well, I mean, the thing was Pfizer started from behind.
Oh, really?
Yeah, I mean, Moderna was working with the National Institutes of Health starting, day one. They started ramping up for their, there's 3 phases of clinical trials. First you test in animals, then you go into sort of a safety trial with people, and then you go to like the bigger efficacy trials. And Moderna was just racing, and Pfizer, like most pharmaceutical companies, was kind of like sitting on the sidelines. Because like the thing about these like emerging diseases like bird flu and everything is everybody gets scared. There's some headlines, and then the thing sort of burns itself out. And that's kind of, in companies, a big company doesn't want to like tell its entire vaccine team, hey, stop making that seasonal flu vaccine that we make money from every year and focus on this, because it's just going to be a waste. And so Pfizer sort of sat back for a while, and then it became clear this is going to be a big problem. And they joined forces with this German biotech company called BioNTech, and they basically moved as fast as they could to be first. They did not want Moderna to beat them, and I think it's clear what they got out of it. I mean, number one, being first across the finish line, you get bragging rights. Okay, they're the status vaccine. We know that, they were able to sign more deals because once their vaccine was proved effective, it's like countries were lining up. So I think, and here in the US, it's like, I don't know, around, like maybe 50% more Pfizer doses have been delivered than Moderna doses.
Oh,
so
wow.
they've benefited greatly from it. They're talking like $30 billion of income of revenue this year from the vaccine. And if they had been second place, I mean, Moderna was a week behind, so it's not a huge deal. But it's like, again, J&J, and nobody, look at Novavax. I mean, they're way, nobody's talking about them.
Yeah.
And there were other logistical problems that people were worried about. It's like, hey, if you're second place, how are you going to get people to enroll in your clinical trial? Everybody's going to want to get vaccinated and not sort of take the chance.
Do you talk in your book about the Russian vaccine? Remember how he was the first, technically?
Yeah, I mean, if you give somebody a vaccine without testing it at all, yeah, you can be first.
Yeah.
It depends on where
they're actually backed up on that now. They can't get enough of it. Is that crazy? That's what they claim. I should probably. That's like reading the first pages of the top Chinese newspapers online. Never mind.
It's really hard to know what exactly to believe with that one. The thing about it is, the Russians have, there's this funny thing where, like, if you have a strong bioweapons program, you probably have a strong vaccine program. So Russians have all these brilliant scientists, they just don't have like the same level of investment, and and we don't really know what they've released, how accurate it is, and there have been some problems.
That's true. I remember when it was like, well, Putin's daughter took it, and you're like, did Putin take it? And I mean, really, in Russia, they need a vaccine for people who fall out of second-story windows accidentally. That's usually what they need a vaccine for. You know what I'm talking about. Let's see. So Pfizer got out first. You profile some of the key scientists behind the coronavirus vaccine. Tell us a little bit about that.
Yeah, sure. I mean, there were so many people that went in and that worked on this incredible endeavor. But one of the guys that I really admire is Barney Graham. He's kind of this 6'5" tall Midwesterner, just a swell guy. Works at the National Institutes of Health, and he works under, he's retired now, but he worked under Tony Fauci, for instance, at something called the Vaccine Research Center. And, he worked on some HIV work, and then worked on this little obscure virus called the respiratory syncytial virus, which actually, it's a pretty important thing, but not many people have heard about it. But all through his sort of dedicated work, he developed this like strategy for attacking coronaviruses, which is, they all have the spike. I'm sure you've heard about it. They're covered in like 40 or so spikes, which is how they get into our body's cells. But the problem, sort of the concern with some of these coronaviruses, is that spike changes shape. And he and his people working in his lab came up with this strategy to basically make a disembodied spike, the spike protein, and have it sort of fixed in a form that your body can develop antibodies to. And because he'd done that, he was able to basically, within 2 days of the gene sequence coming out, send a proposed vaccine design to Moderna.
That's
and
amazing.
The thing about Barney is he's not just a basic scientist. Like, he has a fascinating life story, and sort of getting the vaccine out to, say, the Black community has been very important to him. And he's just he's been a big supporter of bringing in sort of underrepresented voices in his lab. So there was the woman who was doing sort of the mouse experiments there at the NIH, name's Kizzmekia Corbett. And she became a huge Twitter star because she's kind of just a funny woman, a black woman who grew up in Hurdle Mills in North Carolina, and among the tobacco fields, and has become this world-class coronavirus vaccine researcher. And she's just great. So yeah, I think, in the book, I tried to paint the stories of all of the characters that contributed to the vaccine. And of course, again, it wasn't just scientists, but it was, people at the FDA that are, these dedicated, passionate civil servants that made this thing happen. Because the science is just one part. There's the product, there's the delivering the vaccine as well.
Mm-hmm.
Yeah.
So you write about how Operation Warp Speed, what it is, how it works, and President Trump's operation. How influential was this in really helping get the vaccine rolling out and out to people?
Yeah, no, I think that's an interesting question. One of the central problems with vaccines throughout, is that they've never gotten enough funding. The thing is, a vaccine is not as much of a profit maker as a drug, or at least that's what many drug companies have said in the past. And when things were ramping up, it's like, yeah, Moderna was moving fast, and Moderna has some money, but they weren't investing as much. They weren't moving as fast as they could. And other companies, it was kind of the same deal. Johnson and Johnson was saying, oh, maybe we'll have a vaccine in a couple of years. So the Operation Warp Speed really did sort of come together, number one, to put a huge amount of cash into the vaccine race, to get companies to start pre-manufacturing their vaccines. And then also there was kind of some hand-holding involved. And there was actually some friction with this, but in terms of designing the clinical trials in a way that they would succeed during a pandemic was a big concern. I mean, looking back, we think, oh yeah, it was so easy. Sure, the vaccines were successful in November. That's just the way it is. But like, if you rewind the clock to April and May, there was concern there might not be enough cases of coronavirus. The way you show if a vaccine is successful, if it's effective, is by comparing the number of coronavirus cases you have among your vaccinated group versus your unvaccinated group, right? And there was talk that there was going to be this summer lull, and then because everybody is respecting social distancing and masking, we know that's not true. But there was kind of this fear that there wasn't going to be enough circulating coronavirus in the summer, that you wouldn't know if your vaccine worked. And then in the winter, you'd get this tidal wave of cases suddenly coming when people move inside, and we wouldn't have a proven vaccine. And so part of Operation Warp Speed was working with the companies to, initially they thought, okay, there was one proposal to test the vaccines in prisons. There was, because there were all these prison outbreaks there, right? The outbreaks of coronavirus in prisons, but they said, oh, that's not a good idea. Then there was an idea to basically try to track, predict what cities were going to have outbreaks. Because remember, back then, it wasn't like coronavirus was all over the country. It would pop up one spot, pop up somewhere else. And if you want to test your vaccine, you want to be where the outbreaks are. And so there was just this enormous logistics effort to make sure these clinical trials were happening in the right way. In the end, the coronavirus kind of took off, and it was pretty easy to test. But yeah, I think a lot of this is we owe to Operation Warp Speed. And I just to sort of circle back to your point about it's Trump's Operation Warp Speed. This is a big point I make in the book, which I just think is fascinating. Is yes, the president gave the operation, the green light, the approval, but it's the people who created it. The Peter Marks at the FDA, who I already mentioned, and then Bob Kadlec, who was this former spy military man who ran this obscure agency called the Assistant Secretary for Preparedness and Response. That guy was almost fired by Trump multiple times. So it's and then the health secretary, Alex Azar, again, was almost lost his job in April as well. And so it's the group in the health department were basically Operation Warp Speed was their baby, and it basically kept them on the job.
Wow.
And then of course it becomes Trump's legacy. Yeah.
Yeah. I mean, the whole thing of trying to fire those guys and Fauci, and And the nation trusted Fauci more than they did the president, which is kind of weird.
Yeah.
I think people were like, he's to run for president, but he seemed to be more trusted and liked than that. So in the future, is this going to make us better prepared for the next pandemic? Because from what I understand, there's just more coming.
Yeah, I mean, I think that's the hardest thing here. How do you prepare for like just an event that is super unlikely but super damaging, like a meteorite or an asteroid or whatever?
Mm-hmm.
How much money do you want to invest in that? And so Barney Graham, this scientist I told you about at the National Institutes of Health, he what he's pointed out is there's about 25 families of viruses that have viruses in these families, these groups that are potential threats to people. Okay.
Mm-hmm.
And we have licensed vaccines for 12 of those. That means there's been enough research and development that we know how to stop one of them. And so that means we might have a head start if another outbreak occurs in that family. The coronavirus, we were lucky because Barney had done sort of initial research on the coronavirus, so we kind of had a head start. What about these 13 other virus families? His argument is these should all serve as prototype. We should make prototype vaccines to these potential threats. So we should be spending maybe not Operation Warp Speed levels of funding, but a significant amount of funding towards developing vaccines for viruses that have yet to emerge. And that will give us a head start if some random virus suddenly lands in our country again. The Biden administration has ponied up some more cash towards some of this basic research. But the way it is with this stuff, it's like everybody's thinking about it now. Where are we going to be 5 years from now? It's like, oh yeah, coronavirus, right? So it is going to take sustained investment. It's going to take, I'm sure there's going to be a whole new generation of vaccinologists and virologists, right? That's what everybody's going to want to be right now if they're in elementary school.
Yeah.
I think so. But yeah.
So based on your research, do you think coronavirus came from a lab?
That's definitely like a pretty hot button issue. I wouldn't hazard a guess. I'm not one of these people that's sort of strongly in one camp or another. It's certainly, I would say that it's entirely possible. I mean, all of the sort of the information that's come out, basically the general theory is there's a lab in Wuhan called the Wuhan Institute of Virology. They've done a lot of work on coronaviruses. They've collected coronaviruses from the field in a cave. I think it's like 1,000 miles from Wuhan. And the question is, well, did this virus naturally emerge from, say, the wildlife trade, or was it somehow brought to Wuhan by these scientists, and then there was some experiment that went wrong, someone got infected, and they spread it. And it's been interesting how divisive this has been. There's been a bunch of scientists who've kind of rallied behind sort of the Wuhan Institute people sort of locked arms and said this is ridiculous. Plenty of other pandemics have emerged from wildlife, like the first SARS pandemic back in 2002 and 2003. So why is this any different? But and there's part of the problem is that China is not very open, right? They weren't open when they were sort of delaying the release of the coronavirus sequence. They have not been totally transparent with what's been going on at that Wuhan Institute of Virology. And there have been some misstatements by the scientists at the institute that make people very suspicious. And yeah, I definitely get into this a little bit in my book because it was kind of the chatter inside the administration about where this thing came from. And no, we don't have an answer yet, and it seems really unlikely that we're going to have one anytime soon.
Yeah, probably. I believe I had another author on the show where there's some reporting I picked up or scanned over. I collect a lot of data. I read a lot of stuff. I get bored a lot. And there was somebody who said that one of the problems that had been one of the things that had been in the system that was jamming things up was some of the religious people were put over in charge over the health departments and the science departments in the White House, and there was interference they were running with, embracing the science of this. Is that true, or am I not collecting my data properly, or maybe I just got a different opinion from somebody who wrote a book?
Huh? What are you referring to specifically about the use of like fetal embryonic cells and testing with like
No,
vaccines and drugs,
it was
or?
they put over the science divisions or the National Institutes of Health. They put people in the administration that were largely deeply religious. They just believe, well, if you believe in the Bible, I'll do it. I think it was Nina Burleigh's book um,
Mm.
that there was that inference. I'd have to go back and check, so don't quote me. But uh, but anyway, I was just wondering if you'd seen that. So I collect
Well, I
data and
definitely
try.
one of the things I do talk about in the book is the issue around the fetal embryonic cells and
Maybe
cell
that was
lines. Is basically there was a pretty intense debate within the Trump administration in the early days about um, whether they should ban the use of these cells. So
Mhm,
basically, for various studies, scientists will take you know tissue from aborted embryos
mhm,
and will sort of use those cells. They might. I think sometimes they will put them. They'll do what's called make a humanized mice, where they put the cells into a mouse to make it grow human cells in it, or
mhm,
else they'll sort of develop new, sort of get these cells to grow in the line in the lab for several generations, and that's like some of that's very important for doing certain types of vaccine and therapeutic work. And this
mhm,
was this huge debate, and ultimately some more religious members of the administration, Joe Grogan, who is the head of what's called the Domestic Policy Council. It's this
mm,
very powerful group in the White House, sort of won that battle and basically had these cells banned from federal research. The question of how big of a deal that was is kind of hard to say. I think there is some thought that using um, there could have been some benefits for that, but I don't know that it really slowed us down with the vaccine race.
okay. Well, that's good to know. That's good to know because, yeah, that may have been some of it. There was, I mean, a lot of the, Centers for National Policy people were brought in or brought in, pushing that sort of narrative and religious anti-science narrative. And I was
Mm-hmm.
wondering if that effect. Do you saw, on one hand, the Trump administration pushed the Operation Warp Speed, and on the other hand, they started playing it against each other and creating all this confusion and fire Fauci, and then
Mm-hmm.
maybe bleach is better in your neck or whatever, injecting it. Um, it just for argument's sake, if we'd had a better scientifically based or let's just say a more stable genius in the White House, would things have maybe turned out faster and better? I mean, you can say that they did a great job with Operation Warp Speed, but maybe we wouldn't be as bad off as we have been these last few months, or as many people would have died. Is there any? I don't know. Am I just making stuff up and out of thin air?
No, I mean, I think many of us hoped that you thought rolling the vaccine out, once you get the vaccine, like that's the hard part, and then everybody's going to line up to take it, and
Hmm.
and initially there was more people who wanted it than there were doses, and now we've reached this point where there's been this growing resistance to it.
Hmm.
I think like the scale of that movement has been striking even to me. So I actually, this is a little bit of an aside, but I worked on this story a couple years ago about this other infectious disease called Hindra, which is it's kind of like Ebola in Australia. It comes from bats, and then they give it to horses, and then horse owners would end up getting this thing, and within days of catching it, you can die.
Yeah. Wow.
Um, and so it was just this horrible thing, and turns out that and some people develop a company, a Merck subsidiary, developed a vaccine that
Hmm.
you vaccinate your horse and then you can break the chain of infection, right? Shouldn't
Wow.
be controversial at all. But
Yeah.
all these horse owners refused to give their horses the vaccine because they felt it had too many side effects or was killing their horses. And it was just crazy to me that, yeah. And so, I mean, the level of the sort of social variables here have been, during the whole course of the pandemic, the viruses, like, we can understand, we can study, there's like science there, but the sociology of vaccines is a whole other level of the unknown. And so, yeah, I think that the mixed messages we got from the Trump administration delivered, which is, we're going to get a vaccine out as soon as possible. FDA is slowing us down. That made people distrust the vaccine. and
Yeah.
then once the thing was out and it was actually proven effective, then there's been this weird response to it, like, no,
Yeah.
it doesn't work, and yeah, so it is very sad.
Yeah.
Um,
And they took a lot of
uh,
cues from the Fauci, just for a while there, Fauci was, ruling the stand there in the White House in the press room, and then they had
mhm.
him removed because he was making the small guy feel smaller, I guess. So it's really interesting, the whole dynamic of how it went down. And I think you can look at, I mean, we're getting another set of politics here, but I think you can really look at the Trump administration and go, they probably would have rolled right through another president's second term if not for the coronavirus and the way they handled it. If they would have handled it competently, from start to finish. I'm talking about everything. You've covered some, good stuff that they
Yeah.
did, but if everything had been competent and done, we might have been really out of the vaccine, out of the sort of woods, maybe by the time the election rolled around. And I think that's one of the key components of his biggest mistakes.
Yeah, I definitely think that's the case. I mean,
Yeah.
he even with that handicap, as you will, of a pandemic, it's not like he totally bombed the
Yeah,
election.
he wasn't
Um,
that far
yeah,
short when it came down to it.
yeah.
And
I think one of the things that I really found fascinating in working on this book is I do go deep inside the administration and the White House and the health department, because it wasn't just, you know there were quite a few dedicated people, including political appointees, who were trying to solve this crisis, but there was no leadership, right? So the lack
Mhm.
of leadership led to just infighting and power struggles, and doing one thing one day, doing another thing the other day. And I think I like to say that, the first few months of the pandemic, um, I don't think things could have been done that differently. I mean,
Mm.
it we look around the world, and a lot of, countries with, better governance did not fare well. There was scientific disagreement. There was,
Mhm.
it wasn't just political, but it's kind of like when you got into April and May of last year,
Mhm.
that's when it became sort of the political side trying to crush what was becoming the scientific consensus, which was that we need to obey social distancing, we need to wear masks, um, we need to basically slow this virus until we have a vaccine. And that's kind of where things went off the rails.
Yeah. And then people have learned that our hospital systems are a mess. I mean, crazy. This has been a great discussion. I think it's really important that people read these books, understand stuff, and that we really embrace scientists because I mean, technically, basically, they're the ones that saved us on this one, right?
Oh yeah, for sure.
Yeah. I mean, we'd have been screwed without science. I mean, otherwise, it's like, well, pray and see how that works out. But we know how that works out in the
Some
schools.
people are doing that. Yeah.
Some people are doing that. Yeah. I've seen a lot of data recently where um, they've compared people that have the vaccines that survive when there's breakthroughs and people that don't. I know a lot of friends that didn't get the vaccine that have become long haulers now. They've actually gotten it twice. And I know way too many people now at this point that have gotten the twice long hauler thing. We don't, and everyone's like, well, there might be some effects of it, but geez, we still don't even know the long term effects of getting the COVID vaccine, or I'm sorry, getting the
Yeah.
coronavirus. And I've heard stuff from glass lung to, God knows what, especially in young children. And we could end up where, I don't know, these people have higher cases of MS, I don't know, 20, 30 years from now or something. Who knows where this is going to lead? So it's crazy. We can't get it locked down.
Yeah, absolutely. I think getting the vaccine is many times safer than getting the actual virus.
Yeah. Do you think, my last question for you here, do you think we're going to need more than 3? I mean, is this we're going to we're going to be living with this for a while, aren't we?
$1 million question. Yeah. I think that it's the what the scientists told me when I was working on this is, we don't know for sure how long this immunity is going to last. We don't know how, there could be more dangerous variants that emerge, like Delta, which was more transmissible. But I think what we're generally seeing is that the virus is going to be more like the common cold in the future. I don't know how many more peaks we're going to face. People say that this winter is not going to be as severe as the last one, but it could be bad for some people.
Yeah.
But I think the coronavirus is definitely with us for a long time. And maybe in the future we'll have to get sort of a variant vaccine. I don't think that's settled yet.
I'll never forget the first time when I got my first shot from Moderna. It was like a relief. I was like, just knowing that I couldn't die, or there was a real, it was 99% chance I wouldn't die. Just knowing that was just like such a relief and such a secure thing. I mean, you were like, wow, okay, all right. So we got this thing going. So, yeah. Well, thank you very much for coming by, Brendan. Give us your plug so people can find you on the interwebs.
Yeah, thanks. My name is Brendan Burrell. My Twitter is bburrell. Website's brendanburrell.com. Or you can go to the website for the book, thefirstshots.com. Yeah, I'm excited to share the book with people. I think you'll find out a lot about the inside story of the vaccine race that you've never heard before.
Yeah, and I think it will help educate people a lot more too as well. Thanks for coming on the show, Brendan. We certainly appreciate it, man.
Yeah, thanks for having me.
There you go. Thanks, my audience, for tuning in. Go pre-order the book. You want to definitely get a hold of this baby so you can say you're the first one on your blog to read it. And, of course, educate yourself about the vaccine. If you have vaccine hesitancy or you're listening to a lot of, weird news out there, go read the book. Find out what really went on to it. See the study and the science behind it. Learn more about what it's doing, and you get your vaccines, will you? The First Shots, the epic rivalries and heroic science behind the race to the coronavirus vaccine, coming out October 26, 2021. Go ahead and order that baby up. Get it to be the first on your block to do it. Go to all our groups on Facebook, LinkedIn, Twitter, Instagram, youtube.com/Chris Voss, and goodreads.com/Chris Voss. Thanks for tuning in. We'll see you guys next time.